You know, um, imagine for a second that you're sitting at your kitchen table
Oh, okay.
and you are reading the manual for this wildly complex piece of heavy machinery. Like, you read every single page.
Right, cover to cover.
Exactly.
Yeah.
You study the hydraulic diagrams, you memorize all the bold red safety warnings, and you trace the wiring paths with your finger. And by the time you close that book, you feel like an absolute expert.
You've got the whole thing down.
Yeah, you know the words perfectly. But then the very second you step onto the factory floor, walk up to the actual machine, push the big green button, and try to operate it well, everything instantly goes wrong.
Yeah.
The machine shudders, sparks fly out of a vent somewhere, and alarms start blaring. And you have to wonder, why does that happen?
Because knowing the words on a page is entirely different from experiencing the unyielding physical reality of a machine in action.
Yes, exactly.
It's the classic gap between theory and practice. I mean, knowing the operating procedure doesn't mean you have the physical intuition for what actually happens when metal grinds against metal or when pressure suddenly spikes in a closed loop.
And that massive disconnect between describing a physical thing and actually interacting with a physical thing is exactly what we're exploring today. So welcome to the deep dive.
Glad to be here.
We've got a really fascinating internal review draft of a press release to unpack for you today. It's dated today, actually July 13th, 2026, and it's coming to us from a company called EON AI Ventures.
Right.
They are announcing a brand new technology called EON Live. It's a real-time physics runtime designed for their work intelligence platform. And whether you are managing a manufacturing plant, keeping a close eye on the tech sector, or you're just someone fascinated by how AI is finally bleeding into the physical world, you are going to want to hear this.
Yeah, the reason this announcement caught our attention is the fundamental shift it represents for the industrial world.
It's huge.
It really is. Because if you look at the history of digital twins, we've essentially been building better and better static representations. For years, a digital twin was basically just a very expensive 3D model.
Like a video game level, right?
Right. It looked exactly like the plant, but it was hollow. Then, with the boom in large language models, we integrated systems that could describe the plant.
Okay.
But what we are diving into today is that next leap. We're talking about living, physics-driven simulations.
A digital environment where the consequences of your actions actually emerge in real time.
Exactly. Governed entirely by the laws of physics rather than just being pre-scripted by some programmer.
Which is a massive leap forward for how human beings learn, how we train for dangerous jobs, and how we prevent catastrophic industrial failures.
Absolutely.
But to appreciate how big of a leap this is, I think we really need to unpack the core problem with our current obsession with language models. Because the EON document makes a really sharp distinction here.
It does.
A language model can describe an industrial valve in completely exhaustive detail. It can recite a 50-step shutdown procedure to you in the exact correct order.
Yep.
But as the document points out, it cannot run the plant.
And that is the absolute ceiling of relying solely on text-based AI in a physical environment.
Right.
An AI might know the sequence of words in a manual perfectly, but it has no structural concept of pressure building up in a pipe.
Yeah.
It doesn't understand the heat transfer happening inside a boiler. So if you feed procedural steps into a model that only understands language, nothing physical actually happens.
I was thinking about it like this. It's the difference between knowing a recipe by heart and actually cooking in a bustling kitchen.
That's a good way to put it.
Right, like you can confidently recite the steps to pan-sear a perfect steak.
Yeah.
But if you don't understand that the cast iron pan is physically getting hotter every single second it sits on that flame, and that the rendering fat is eventually going to hit a flash point and catch fire, your memorized recipe is totally useless. The words do not stop your kitchen from burning down.
That captures the limitation perfectly. EON frames their technological evolution precisely around solving this kitchen burning down problem.
Okay.
They actually describe their platform's development as climbing a ladder with 3 very distinct rungs.
Yes. Looking through the source material, rung 1 is what they call Genesis.
Right.
And this seems to be their baseline engine. Its primary function is essentially playback. It replays a procedure step by step, almost like a highly interactive digital instruction manual. So it knows the sequence step 1, step 2, step 3.
That's the baseline, yes.
Right.
Just procedural playback. Then they step up to rung 2, which they call EON Universal.
EON Universal, okay.
Now, this system introduces a level of sophistication. It understands the equipment well enough to branch out its procedures based on a known fact.
Right. The document uses a pump to illustrate this, which really helped it click for me.
It's a great example.
Yeah. EON Universal knows a specific fact about this pump, that it stores pressure even after the main power is turned off. And because it knows that static fact, it can author a procedure that branches off to account for it.
Exactly.
The system essentially says, okay, power is off, but beware, there's still trapped pressure here.
Right. So it's reasoning, but it's reasoning based on static facts in a database.
It's still just words.
Exactly. It's intelligent, but it's still fundamentally operating in the realm of logic and text. Which brings us to rung 3, the real focus of today's announcement, EON On Live.
The big one.
And here is where the paradigm completely shifts. In EON Live, pressure is no longer just a static fact stored in a database for the system to reason about.
Okay, so what is it?
Pressure becomes a live dynamic variable. It is genuinely present in the simulation, it physically propagates through the network of digital pipes, and it decays over time based on actual fluid dynamics. If we connect this to the broader concept of physical AI, EON Live is taking the platform's existing understanding of the equipment, the geometry, the individual components, and fusing it with a live physics engine.
Okay, let me stop you right there because this is where my alarm bells went off when I was reading the release.
Oh, yeah.
Yeah. Let's say we are talking about a massive offshore oil rig or a sprawling chemical refinery.
Sure.
To get that level of physical accuracy, to simulate every drop of pressure, every thermal fluctuation, every bit of fluid dynamics, don't you have to build an unimaginably complex custom 3D physics model from scratch for every single facility?
That's what you would think.
Because that sounds like it would take years of consulting work and cost an absolute fortune just to model one single factory.
It's the most logical objection to have. I mean, everyone assumes that bringing physics into a digital twin requires this massive bespoke engineering project.
Right.
But according to the source material, the answer is no. EON Live is built on something called the Babylon engine.
The Babylon engine.
Yeah, this is a highly scalable runtime framework capable of rendering massive environments and complex physics instantly. But the critical detail here is that EON's approach requires no second capture and no second model.
Okay, I need you to break that down. What does no second capture actually mean in this context?
Well, it means they don't have to send a team out to laser scan and build a brand new physics model for every facility.
Oh, thank goodness.
Right. Instead, EON Live simply consumes the component model that their Rung 2 system, EON Universal, is already producing.
Okay, I'm trying to visualize this. So the platform already understands what a standard pressure valve is. It knows what a section of pipe is, how they connect, and how electrical isolation works. The release refers to these as typed components, right?
Right. Think of typed components like highly intelligent digital Lego blocks.
Lego blocks, okay.
Each block comes with its own physical rules already built in. A standard pressure valve block knows how it should behave under stress, regardless of what factory it's bolted into.
Oh, I see. So instead of trying to ingest and memorize an entire massive oil refinery as one giant, rigid 3D object, EON Live just looks at the map of Lego blocks it already has.
Exactly.
It knows how the pump block connects to the pipe block. And because it already knows the DNA of the individual parts, it just turns the physics engine on.
Yep, it wakes the map up.
It wakes it up. And the simulation automatically calculates how the fluid moves between those specific blocks.
It's an incredibly elegant solution to the scaling problem. EON Live executes the physics on the typed components themselves.
They don't have to rebuild the world.
No, it adds the live simulated behavior right on top of their existing platform. It doesn't replace the old model, it just makes the old model behave.
That makes so much more sense. It's system-wide causality built from the bottom up. And there's a phrase in this press release that perfectly captures why grounding this in physics is so crucial. Internally, EON refers to this by saying physics doesn't hallucinate.
It's a brilliant line, and it takes direct aim at the biggest vulnerability of generative AI right now.
Because we've all seen language models confidently invent facts, right? They hallucinate information that sounds totally plausible, but is completely wrong.
All the time.
Now, if you were asking an AI to summarize a meeting, hallucination is just embarrassing.
Right.
But if you were asking an AI how to safely stabilize a high-pressure gas line during a power failure, a hallucination is lethal.
Exactly. When dealing with safety-critical infrastructure, you simply cannot rely on a system that might occasionally guess the wrong answer based on statistical word prediction.
No.
Physics is absolute, Gravity doesn't guess. Fluid dynamics don't hallucinate.
Yeah.
If you restrict a pump that needs fluid, it will cavitate every single time. EON Live grounds the simulation in that unyielding physical reality.
Okay, you mentioned a pump cavitating, and the document actually highlights a starved pump cavitating as one of its specific examples.
It does.
For those of us who aren't mechanical engineers, what actually happens physically during cavitation?
Oh, it's a fascinating, well, highly destructive process.
Destructive, got it.
Yeah, so when a pump tries to pull in liquid but the flow is restricted, say, a valve is closed when it shouldn't be, the pressure drops so low that the liquid actually vaporizes.
Wait, it vaporizes?
Yes, it boils into bubbles. But as those bubbles get pushed into the higher pressure side of the pump, they collapse violently.
Oh, wow.
They implode. And those micro-implosions are so powerful, they will literally chew away solid metal, destroying the pump from the inside out.
That is wild. Okay, so if the system natively understands that closing this valve will cause that pump to literally chew itself to pieces, think about what that means for a brand new operator stepping onto the floor.
Exactly.
Which brings us to the practical applications. The document outlines how this physics-driven approach changes the game across 3 main domains. And the first one is the training center.
Historically, a lot of industrial training has come down to reading manuals and passing multiple-choice quizzes.
Yeah.
But a quiz doesn't test your physical intuition. It doesn't test how you react when the alarm sounds and the pressure gauge is spiking. With EON Live, trainees can operate a unit and be corrected by physics rather than by a pre-written script.
Yes, the press release specifically notes that trainees can rehearse what they call transients, the startup and shutdown phases of an operation.
Right.
And it makes a point to say that these transient phases are where most actual incidents occur in the real world.
Because that's when the system is vulnerable. That's when states are changing, when pressures and temperatures are in flux.
So instead of taking a paper test on shutdown procedures, a worker is assessed on how they actually stabilize a live upset in the simulation.
Exactly. They can push a pump too hard until it starves and begins cavitating. They can overpressure a vessel just to watch it physically lift its relief valve.
They get to see the physical consequences of a mistake without anyone getting hurt.
Yes.
It's basically a flight simulator for blue-collar professionals.
Yeah.
Like, a commercial pilot doesn't learn how to handle dual engine failure by taking a written exam.
No, they get in the simulator.
They get in the simulator and they crash the virtual plane 100 times in a safe environment until their instincts take over. Now, the person running the chemical refinery gets to do the exact same thing.
And the value of that kind of experiential learning, I mean, it's immeasurable, but the utility of EON Live doesn't stop in the classroom.
Right.
The second domain the document highlights is the field. This is for the technician who is actually out there with a wrench in their hand.
Right, because training is a safe room. But what happens when you are standing in front of the actual machine?
Well, imagine a technician is about to perform maintenance on a complex system. With EON Live, they can simulate their exact next move before they make it in physical reality.
Oh, that's smart.
Yeah, they can validate that their lockout procedure truly isolates the specific work zone they are about to enter, proving the safety protocol in a live physics environment before they put their hands on the equipment.
That is incredible. But the document mentioned something else about the field that totally blew my mind using live telemetry.
This is where it bridges the gap perfectly. The digital twin can be fed by real-world telemetry live data coming straight from the actual sensors on the physical machine.
Okay.
So if a technician sees a bizarre temperature reading in the real world, they can look at the EON On Live simulation, and the physics engine can explain exactly why that specific reading is happening based on the fluid dynamics and component states.
It essentially gives the worker diagnostic X-ray vision into the physics of the machine.
That's a great way to describe it.
Now, if you have a digital environment that perfectly mimics the physical one, you wouldn't just use it for the people operating the plant, you'd use it for the people designing it.
Absolutely.
Which brings us to the third domain, engineering.
Right. It allows engineers to test modifications before a single physical pipe is ever cut or a foundation is poured. Let's say you want to reroute a flow network to increase efficiency.
Sure.
You can run that proposed blueprint through EON On Live and physically watch for issues.
And the document specifically mentions watching for dead legs. What is a dead leg in this context?
A dead leg is a section of piping where the fluid doesn't flow properly. It gets trapped and stagnates.
Oh, okay.
Over time, that stagnant fluid can cause severe corrosion or harbor dangerous bacteria, eventually leading to a rupture.
Yikes.
Yeah. And it's a design flaw that can be really hard to spot on a static blueprint. But in a physics simulation, you would instantly see the fluid dynamics stall in that specific section.
You'd also see vibration issues or unexpected pressure drops across the new network. You are fast-forwarding the physics to see if the design actually survives contact with reality.
Exactly.
But this brings up a huge question regarding scale. EON built this for an oil rig, dealing with high-pressure fluid dynamics. But what about other industries? Can a system like this truly scale across different sectors?
This is where that typed component architecture we discussed earlier becomes a massive competitive advantage.
The Lego blocks.
Right, the Lego blocks. Because the runtime executes on the individual components rather than a rigid, hard-coded memory of a single facility, the exact same physics engine transfers across entirely different industries.
Because the physics governing a pipe is the same, whether that pipe is moving volatile crude oil or drinking water in a municipal plant.
Exactly. The source notes that oil and gas is their first target domain, which makes total sense. It involves highly complex pressure systems, flow networks, isolation, and dispersion.
Yeah.
But because the underlying Babylon engine understands those core components natively, the application applies directly to mining operations as well.
Wait, mining? Like subterranean operations?
Yes, specifically for critical infrastructure like mine ventilation systems and dewatering networks.
Oh, wow.
Yeah, it's all just complex fluid dynamics and pressure routing. The document also lists power load flow and switching for the energy sector, water hydraulics, and even process and pharmaceutical operations.
That is an incredibly broad net to cast. I mean, to pull off something that ambitious, to claim you can simulate the physics of a pharmaceutical plant in a subterranean mine, you need some serious infrastructure and a massive amount of historical data.
You really do.
So what is the actual background on EON AI Ventures? Do they have the track record to back this up?
The corporate context provided in the source is actually quite robust. They aren't some new AI startup that just pivoted into the industrial space yesterday.
Okay, good.
They have 25 years of experience, specifically in immersive learning, and they currently support over 4,400 institutional customers across more than 80 countries.
So they have deep, established roots in this space. They already have the data.
They do, and they operate on a guiding concept they call work intelligence.
Work intelligence.
Yes. Their entire mission is to capture exactly how work is done in the real world, the procedures, the component behaviors, the safety protocols, and turn that accumulated knowledge into an owned, compounding digital asset for the enterprise.
That makes sense.
They refer to the engine driving this as their intelligence flywheel.
You know, there are a couple of quotes in the release from the EON hand leadership team that I think really crystallize what their ultimate vision is here. Mats Johansson, the president, makes a very sharp point about what the market actually wants. He says, our customers do not need another content library rebuilt site by site.
Which points right back to your earlier pushback about bespoke 3D models.
Exactly.
No enterprise wants to pay a consultancy to laser scan and build a virtual reality model of every single factory they own over and over again from scratch.
Right. Instead, Johansson argues that they need one behavioral runtime that compounds across every asset and every industry. He's saying the value isn't in how beautiful or accurate the digital twin looks. The value is entirely in how it behaves.
And that ties perfectly into the quote from Dan Lajerskar, the founder and chairman. He frames EON On Live as a culmination of their 25 years of capturing industrial knowledge.
Oh, this is the good quote.
Yeah, it says EON Live is the moment that knowledge starts to behave. And then he delivers this incredibly weighty line. This is how we turn bytes back into atoms.
Turning bytes back into atoms. It sounds like a philosophical statement, but it's remarkably literal.
It really is.
Because we've spent the last few decades turning physical atoms, the real world, into digital bytes of data. We put sensors on everything, we tracked everything, we stuffed it all into massive databases.
Yeah.
But EON Live is taking all those digital bytes, running them through an unyielding physics engine, and projecting physical consequences back into the real world.
It completes the circle, from the physical to the digital, and now using the digital to perfectly predict and manipulate the physical.
So let's take a step back and synthesize the journey we've been on today.
Sure.
We started by looking at the evolution of the industrial digital twin. For years, they were static visual models. They just looked right. Then we introduced large language models, which were fantastic at reciting manuals and procedures that they could describe what was right.
Yes.
But today, we've explored EON Live, representing this massive leap to a system that actually behaves right, governed entirely by the laws of physics. It's an environment where consequences genuinely emerge rather than being written in a script.
It completely redefines the relationship between the worker and the digital tools they rely on.
It really does.
But, as we consider how this technology will actually be deployed in the field, it raises a rather profound dilemma.
Oh, how so?
Well, we discussed how EON Live uses live telemetry to perfectly predict physical outcomes, giving workers diagnostic X-ray vision.
Right.
But if we extrapolate that into the future, think about the human element. For generations, the most valuable asset on a factory floor or an oil rig has been the veteran worker's intuition.
Yeah.
That gut feeling, developed over decades of hard-earned experience, that tells them when a machine just doesn't sound right, or when a procedure feels unsafe.
Right, the human instinct that saves the day when the manual fails.
But here's the question we have to ask ourselves as these technologies mature. If a technician is standing out there in the field, and their own human intuition tells them that a machine is safe to operate, but the physics-driven, telemetry-fed digital twin, a system that does not hallucinate, that calculates millions of variables, instantly predicts a catastrophic failure on the very next step, who makes the final call.
Wow.
As these living simulations become completely flawless at predicting physical outcomes that human beings simply cannot see, we might very soon face a world where trusting your gut on the factory floor is no longer considered the mark of a veteran. It might be considered the most dangerous liability of all.
Are we ready to completely surrender the wrench to the simulation? That's a heavy thought to leave you on. Well, thank you for joining us on this deep dive into the EON Live announcement. Keep questioning the world around you, keep looking for the physics behind the words, and we will catch you next time.